Welcome to Academic Digest class. So today we'll be treating action of dielectrics, molecular view of dielectric effects, electric polarization and induced dielectric effects. So first of all, action of dielectrics simply revolves around polarization. And we know that polarization can be explained as, is defined as equal but opposite characteristics, opposite extreme equal but opposite extreme characteristics. That's what polarization means. So when you hear that something is polar, for example, it can mean north or south, east or west. So they are opposites. So it can also mean positive. It can also mean positive or negative. So when I hear non-polar, it means that they are fused together. So let's say this is maybe a particular positive charge, and then there's a negative charge behind it. So they are fused together. You can't see it. But when you now, so I say bipolar, okay, you can also have this to be. So that is what polar means. So non-polar simply means they don't have extreme characteristics. But if you put electric field, if you put a non-polar material under electric field, you see that they will now separate. You now have the positive one side, the negative one side. They will separate. But the only advantage that non-polar has is that once you remove the electric field, it will easily on to presence of electric field. Now on the absence of electric field, it will go back. Non-polar states. So proper examples of non-polar are molecules. H2, Cl2, O2, etc. So I talked about non-polar, so I don't forget it. Let's focus on the main thing, the main action of dielectric, which is polarization. And we know that if it does polarization, it simply means that it tends to move even the non-polar. Once electric field is there, even the non-polar, everything polar, to exhibit polarization. But you can come to think of it and say, how can how can uh, insulators insulators have charge? So you need to now go and remember that there is something called subatomic particles, and everything has it. So every particular object on earth, just like those dielectrics, naturally, see what the action talks about. Naturally, those dielectrics will have positive and negative. That is positive surrounded by negative charges, positive surrounded by negative charges, positive surrounded by negative charges, positive surrounded by negative charges. So the random positive surrounded by negative charges. We know that there's something called neutrons too, but we are not looking in that direction. So surrounded by negative charges due to subatomic particles. Now, on introduction of electric fields, or let's say when we carry these dielectrics, so introducing dielectrics that is not air or vacuum to plates of a capacitor. On introduction, what will now happen is that this one that is random here will now come and say, okay, if this is the dielectrics, and let's say this is right here, and let's say this is also right here. Let's say that this side is positive side of the plate, and let's say this side is the negative part of the plate. What you experience is that those random charges will now come and say negative go towards the positive. It will be attracting it. So you see that the positive side will come towards the negative side. They will now have orientation. That's what it means. They will now have orientation. So you now have negative moving this side, positive this way, negative, positive going towards negative, then negative going towards positive. So this is what happens with dielectrics, and this is what we call polarization. So you can see that by the time you check it well, you see that the net effect that you have here is simply that everything you have on this end, on this, will now have negative, 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 because the positive will totally be cancelled out, while the negative will totally be put to this side. Positive, positive, positive. So this is the action of dielectrics. And because of this, you can see that if you remember when we started our class, as electric field tends to flow on this side, we can call this the initial electric field. On this other end, you remember that in our electric field line, we move from positive to negative. You see that on this other line, there will be electric field because positive is in a different direction with the normal plates of the dielectrics. So you see that the electric field will be here as well. So you see that this one now will now be as a result of the fact that you introduced a dielectric, and this is what we call the induced electric field. So because they are moving in opposite direction, so you say because they are moving in opposite direction, it will not be like dynamics. When you have force and friction, we now have total electric field to be equals to the initial electric field minus the induced electric field. So you can see that if normally the electric field is supposed to be the whole of this, you now have to subtract this one from it. So it simply means that electric field decreases. And why we normally put this dielectric is because air or vacuum, when we have air, it ionizes. So I want to write it here. Note, because air ionizes and starts taking parts in what happens when in capacitance. So we introduce beta dielectrics. So you need to note this. So, and when electric field decreases, then even if you remember, E equals to V over D. You see that E is directly proportional to voltage. So that means that voltage also decreases. So from E equals to E naught minus E induced. So we can get E induced to be the subject formula. Say E induced will be equals to making the subject of the formula is the same. E minus, like this one go over here, becomes positive. Please go over here because I'm trying to check something. E yes. 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 So E not like, yes, what am I even doing? Why is my mind here and not here? So if this one crossover, it becomes positive. If this one crossover, it becomes negative. So E naught minus E. So this is what you have for E induced. But because we are not doing children things, we need to go back to this place, to this formula. If you remember when we did this course, I'm using this to write a textbook too. So that's why I'm following everything in order. I don't write and throw away. So you see, when we discovered this, we said that E electric field itself is equals to E naught over K. So we can come and replace this electric field here with E naught over K. So we say E induced will be equals to E naught minus E naught over K. So you see that you can make subject formula so that this now becomes E induced is equals to E naught minus, is equals to, yes, E naught, factoring out into 1 minus 1 over K. Yeah. So you have this. But you need to remember, if you remember our former classes, we said that this surface density is equals to charge over area. Yes. And that Q is equals to surface density times area, if you remember. Yes. So it is now up to us to always remember that if that is the case, we should have charge induced and initial charge, and we should have surface density induced and initial surface density. We need to remember these things, because we are dealing with induced and initial here. Induced electric field and initial electric field. So for that reason, we need to compare. So I can now come here and say, okay, electric field, if that is the case, electric field, if you remember, from Gauss law, I'm trying to save space because I have something I've written at the back of this. From Gauss law, EA is equals to Q over E naught. Go and read, go and look at it again. So that if you do it, you now see that this is now going to be E equals to Q over E naught A. Now remember that Q is equals to this here, see. So surface density A all over E naught A. Cancel, cancel. So E is equals to surface density over E naught. So you now need to remember that everything we have here. So let's say that means that we can now have this to be E naught equals to surface density naught over E naught, and then E induced to be equals to surface density induced all over E naught. So you need to know this. So if we put it together, you can now see that if we put it inside this place, we can now have surface density induced all over E naught equals to surface density initial all over E naught, then 1 minus 1 over K. So you can see that they have something in common. And even if I say, let me divide both sides, this thing that you have here, everything here is the same thing as saying E induced all over E naught equals to 1 minus 1 over K. So I can leave my answer this way. So the two are equal. So if I know this, I can also go back to this formula inside this E induced and this E naught minus E naught over K. This is the main formula, or you call it this. This thing is the same thing with this. So it's equal to this. So I can go back to this formula and introduce and say, okay, at the point where I have this charge, yes, at the point where I have charge, yes, at the point where I have charge, I'm trying to draft it. So I can say, at the point where I have this, that is this. Let me say I come and say E induced now. Remember that we said that E induced, sorry, look at this here. Look at this here. E is equals to Q over E naught A, Shebi? So we can say that, for example, see, this is surface density. Let's look at this here. Surface induced. Look at surface induced over surface initial. So we can say that if surface density is equals to Q over A, it simply means that surface induced will be equals to charge induced all over A, and surface initial will be equals to charge initial all over A. So you see it. So let me carry these formulas for surface density now and put for it, so that you now have charge induced all over area divided by, everything here is for surface induced, all over charge initial divided by A. You can see that if you do the mathematics well, A will cancel A, so that I now have 1 minus 1 over K. And you know that this is the same thing as saying, this now becomes, I'm trying to save space because I've already written questions I'm going to solve here, but no problem. So this will now be the same thing as saying Q induced all over Q naught is equals to 1 minus 1 over K. And if you choose to make Q induced subject of the formula, you will see that you now have Q induced is equals to charge initial into 1 minus 1 over K. So there you have it. So whenever you hear anything like induced charge or whatever, know that what they are talking about is action of dielectrics. I try to not express everything I have in mind because of the space I'm trying to save. But how we are going to do it is pay attention to the problem class. In the problem class, I'll use style to throw light on those things I'm supposed to elaborate on. Like when I'm solving these questions here. So I'll take time to elaborate on those stuff. Thank you. Remember to subscribe to my channel so you can even be trying the questions on your own while waiting for hours. Bless.